Hey everyone, so today we'll be learning variables, constants, and data types. These are very fundamental concepts to each and every programming languages, and like these are uh, the very foundations of Java. All right, so let's begin with the first concept, that is a variable. I am sure you have heard of variable somewhere, right? In your maths class, probably. You might have done algebra or something, and you have heard about variables, right? So in mathematics, we generally say let x be 25, or let y be 30, or something like that. So that's it. That's just a variable. Think of variable like a ball. It's just a ball. You can keep items on it. That's pretty much it. So basically, if I have to define a variable, it's a value that might change. All right. So first of all, let's see what a variable looks like. So if I say x is 120, x is equals to 120. So what's the variable? X is the variable. What's the value? 120 is the value. Think of it like this: x is the ball, okay? X is the ball, and 120 is like the food that you keep in this ball, okay? So let's go to the next example. Y is equals to Ravi. So in this case, what's the name of this ball? The name of this ball is Y. What's the value going into the Y? I mean, into the ball? It's Ravi, right? Okay, let's come to the third example. Z is equals to 14.3. What's the name of the variable then? It's Z. So what's the name of this variable? This is the variable. Think of variable like a ball. This is it. What's the value going into that? It's 14.3. So that's pretty much it. This is the variable. Now, let's say, for example, your age right now. Let's say your age is, let's say, 35. What happens after 5 years? What happens after 5 years? Your age becomes 40, right? So age becomes 40. Did you see the value changed? The value changed. And that is why I say variable is a value that might change. It changed, right, after 5 years. So this is how the I mean a variable looks like and works, okay? In the same way, let's say 5 years later you change your name from Ravi to, let's say, Ravish. So what would you do? Right now, y is equals to Ravi. Later you might say y is equals to Ravish, and that is absolutely fine because this is the variable and this might change. So that's basically what a variable is. I'm not going into the context of Java, that I'll go later on, but for now, understand that this is the foundational concept of a variable. All right, okay, cool. um Value can be a number, a string, all these things, and these are called data types. We'll go into that later on. Okay, let's go to the next concept. The next concept is constants. What is a constant? It is exactly like variables that will never change. Do you see the difference? Again, this is just a ball. All right, this is just a ball. The name of the ball is water. We are good with it. The value going into the ball is H2O. That's cool. But this will never change. Like, you understand, right? The chemical composition of water will never change. It will always be H2O. So this is a constant, right? There are there are various ways to write a constant and a variable in Java. We'll look on to those later on. But for now, understand this is a constant. Any value that can never change is a constant. Like for example, the value of pi. You must have used pi in your mathematics. So pi is basically 22 divided by 7. That is pi, right? This will never change. The value of pi is always the same. What like sun always rises in the east. It will never change. It will never become west or south or north. This is a constant, right? So you generally use constant for these purposes. So for example, if I say x is equals to 120, for example, this is the let's imagine this is a variable. Okay, this is a variable, and later on I say x is equals to 110. This is correct if x is a variable. But if x is a constant, what will happen? Let's say x is a constant, so x is equals to 120. Now later on I say x is equals to 110. This is not gonna happen. Java will give me error because constants are values that will never change. Okay, you cannot do this in Java. If x is a constant, so that's the basic difference between constants and variables. Variables can change, constants cannot change, and both might look like same, but they are not the same. All right, so let's go to the next concept. Right now I'm just into the theory part. I am not yet touching the practical section of it. I will go into that later on. So this is again one of the most important concept in Java. Okay, in Java, the most important thing is that every variable or a constant must have a data type. What is a data type? The name itself says data type. I mean, the type of a data is a data type, right? It's that simple. The type of a data is a data type. Perfect. So there are many different data types in Java. Integer, float, double byte, long, blah blah blah. There are a lot of things. But now let's see what this statement means. Okay. This statement basically means we cannot say x is equals to 20. In Java, we cannot say this. In Python, we can say, because that's a different programming language that works in a little bit of different way. But in Java, we cannot say that. Java will not understand what is this. Java will be confused. So we have to write like this. We have to say int x. What is int? Int is basically integer. What is an integer? Integer is anything, like anything negative or positive number is an integer, right? We know that from mathematics. So we have to define that x is an integer variable. What? X is the name of the variable, integer is the type of the variable. Okay, so x is the name of the variable, integer is the data type, is the data type of x, right? And 120 is the value. Okay, so you have to define three things: the data type, the name, and the value associated. Okay, we cannot directly write x is equals to 120. That is not valid in Java. Okay, we cannot do that. So for example, if I say let's say I want to use a data something like 50 point, let's say 58.6. Now if I say that int x is equals to 58.6, that is not gonna work. Why? Because I said the data type of x is integer. int and this is not an integer, right? This is not an integer, this is just a rational number, this is the decimal number. No decimal number can be an integer. Nope. So that will give me an error. Okay, only integer value can go into a integer variable, right? So for example, if I say something like this, let me do it once again for your understanding. If I say something like this, okay, let me clear all this out. Okay, perfect. Okay, so for example, if I say int x is equals to 150, is it valid? Yes, it is valid. If I say x is equals to 292,816, is it valid? Yes, this is valid. Why? Because this is an integer. As simple as that. This is an integer. Okay, and we are good, and we are good with it. But if I somehow say x is equals to, let's say, Ravi, if I say this, what will happen? This is wrong, because Ravi is a text. It's not a number, right? It's not a number, it's not an integer. So this will give me an error. We cannot do this. Okay, so let me remove that as well. Let's say I say int x is equals to 14.2321. Is this correct? No, this is not correct. Why? Because this is a number, that is fine, but this is not an integer. It's a floating number, or it's a double number. I mean this is not an integer, right? So this is not going to work. So you have to make sure the data type which you define, the value must be like that only, otherwise it will give you an error. It's as simple as that. Now, just to understand, there can be multiple data types, right? In numbers, we can have numbers like 10, 20, 24.68, 52.55. All these are numbers, right? These are numbers, but there are different types of number. For example, integer, byte, long, short, these are very similar. There are differences. So these two numbers, 10 and 20, it can be an integer, it can be a byte, it can be a long, it can be short. That's cool. But these two number, okay, this is a special one. See, this has a decimal. Any decimal number cannot be integer, byte, long, or short. It has to be. It has to be either float or double. Okay. So this is all about numbers. We'll definitely go into the details of each and every data type. Just have patience. Just hold on. Okay. So the next type is text. Text is like, let's say, um, let me think of a name. Megha. This is the text. Or maybe, uh, I guess mm, okay, I'm bad at remembering names. So maybe Rupa. This is a text. What about single character? A, single character. B. So there can be two different type of text. The first one is string. String is a combination of multiple characters. So you can see there are 5 characters, right? I mean, this is a single character. These are multiple characters. So whenever you see multiple characters, like multiple alphabets, so there are 5 alphabets, there can be 10 alphabets, unlimited alphabets, right? I mean, not really unlimited, but yeah, a lot of alphabets together. This is called a string. And the most important thing is that whenever you define string, you have to use double inverted comma. Do you see these things? This is the same thing which we used during Hello World. Hello World was a string, right? It is a combination of multiple alphabets, including space and all the different characters. So whenever we define a string, we use double inverted commas. So that is a string. There can be another data type which is called character, or simply char. Char can only take one alphabet. Only one. It can take A or B, but it cannot. You cannot do this. I mean, if I say char is the data type, Z is the name of the variable, you cannot say hello. This is wrong. Why? Because char can only take one alphabet, right? So you can do this instead. You can do this. You can say H, or maybe H. Any capital or small doesn't matter. But the whole point is it can take only one alphabet. That's it. If you have to define multiple things together, like a name or an address or something like that, do not use char. Use string instead. Okay. Use something like this. String. This is the data type. Y. This is the variable name. Then you can go ahead and say hello. This is correct. Why? Because the data type is string. This is a string. You are using double inverted commas. Whenever you are defining a character, use single inverted commas. Whenever you are using string, use double inverted commas. Okay, getting the point? Like I can say char a is equals to x. Do you see I am using single commas, single inverted commas, right? So that's all about the string data types. right? Let me go to the next data type. The next data type is Boolean. So Boolean is all about true and false. You have answered questions which have only two answers, either true or false. Like if I say, the sun rise in the east, what would you say? Yes or no? True or false, right? Is this true? Yes, this is true. If I say, uh, if I say color, uh, color of let's say sky, color of sky is maybe brown. Is this true? No, this is false. So Boolean can only have two things, either true or false. That's all about Boolean. And we are going to use Boolean after a while when we are doing a lot of if-else statements. Not right now, but later on. Boolean is a very important data type. For example, to define Boolean, we can say bool, just say bool. Bool is a data type. Just write the name of the variable. Bool x is equals to true. Do not put any commas or anything. Just say true. T should be small. Okay. Hit a semicolon. This is perfectly fine. Say bool y is equals to false. This is correct. This is correct. Okay. Only two things, true and false. Nothing else will be supported by bool. So what is the data type again? The data type is the bool. What is the name of the variable? X. What is the value of the variable? True. Three things: data type, name, value. That's how it goes. Okay. And then we have another thing called class, which we are not going to study right now. Later on. Okay. Just know that there is a way to define custom data type using classes, but we are not going to study class right now, as this is a very foundation to the data types. Right. Now let's go to the next thing. Okay, so we need to understand this very carefully. Okay, let me take my laser. Let me take my pen. Okay, so this is the important area that we have to cover. Very important, right? Very important. This can be done later on. You know this. This is the string which I showed you just right now. But these are called non-primitive data types. Okay, these are not built into Java like directly. It's not raw. It's not raw. These are all raw formats, right? So obviously in numeric types we have byte, short, int, long, and these all are integers. I know it's kind of confusing. Even int is an integer, short is an integer, byte is an integer, long is a, but have patience with me. I'll show you why it is, why all of them are integers, right? Then we have floating point numbers. We have float and double. Now again you might ask, float. Okay, float is a floating point number. Double is again floating. What's happening? Hold on. Let me explain each one of them. Then we have boolean. Okay, there is a typing mistake. Don't worry about it. And then we have char non-numeric data type. So these are numbers. These are not the numbers. Uh, I mean, boolean is true or false. Char is a single character. We know that, right? So this is very important. Okay. So we're going to study all of these in very depth. All right. So let's begin with the first thing, which is our very favorite integer. How do you define an integer? It's very simple. You write the data type, you write the name of the variable, and you put the value 1, 2, 3. It's that simple. This is how you define an integer in Java, right? That's cool. But understand two things. An integer has a size of 32 bits, which is basically 4 byte. Just to just to remind you, bits and bytes. I'll just give you a brief hint. Okay, let me give you a brief hint. So again, the smallest unit in a computer is a bit. What is a bit? Either 0 or 1. That's a bit. Okay, this is the smallest unit. After that, everything builds. Now, when I combine 4 bit, what is 4 bit? 4 bit can look like 0001 or maybe 1001 or maybe 110, any combination, any combination. 4-bit is one nibble. Okay, one nibble. When we combine 8-bit, what is 8-bit? Let's say 0, 0, 0, 0, 1, 1, 1. Let's say 0, 1 or something, like any combination of 8 bits. What is this? It is called 1 byte. We can say 1 byte like this, 1 capital B. When I say 1B, it is 1 bit. When I say capital B, it is 1 byte. Okay, so this is 1 byte, right? After byte, it just goes like this. From here we start. 1024 byte gives you 1 kilobyte. Again, you start from here. 1024 kilobyte gives you 1 megabyte, and so on, right? We don't go into the details because that this is not a conversion class, right? But just understand this thing. 8-bit gives you 1 byte. It's that simple, right? Let's go back. So 32 bits gives you 4 byte. How do I get that? 32 divided by 8. What do you get? 8 4s are 32. That is 4 byte, right? Hope the calculation is clear. Divide this by 8, you will get the number of bytes. Okay. Remember, the range of integer is this. This is a negative one. This is a positive one. So if I say, practically speaking, if I say something weird like -111016298 or something like this. How many digits? 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9. Okay, this is still an integer. This is a negative integer, right? Or we can say something like this. 29601134. Even this is an integer. That is perfectly fine. But remember, int only supports from this range to this range, which is enough, I know. But there are many different types of data types which you can use for the same purpose, and it will save your space basically. So let's say you have something, for example, you have something called, let's say, int x. You say maybe 15,000. Is this correct? Yes, this is correct. This is perfectly fine. But this is wasting a lot of space. Imagine, imagine this is the maximum number you can store. And what are you storing? 15,000. It is wasting your space because every variable that you use, every variable that you define takes up space in your RAM. Okay, let me show you that thing as well. Let's say this is your RAM, a random access memory. Your program is running. This is your Java program. Okay, this is a Java program. Now you're defining, uh, let's say you are defining int x is equals to 15,000. Okay, so for example, this is the maximum capacity of int. This is the maximum capacity of int, right? What are you using? You are using this, only this portion. What happens to this portion? It gets wasted. Okay, it gets wasted. Let's say even if you define int s equals to, let's say, maybe 51,000,000 and you add, let's say, 9 or something like this. Even then also, maybe every time you define something, it takes space in your RAM to the maximum capacity. What is the maximum capacity of integer? This is a big number, right? What are you using? Maybe up to this, I guess. Maybe up to this. What happens to this space? It gets wasted, right? So how not to waste space? How not to waste space? If you have to define 15,000, you can even use short, right? Because it takes, this is the range of short, minus 32,768 to plus 32,767. I know there is still wastage, but at least I mean there is wastage, but very less, right? For example, if I say this is your RAM, okay, this is your RAM, you define something like this: short y is equals to maybe 15,000. Okay, now what is 15,000? half of 30,000. So for example, you define a short variable. This is the maximum capacity. Let's say 30, approximately 30,000. This is the full capacity, right? You are using 15,000, which is basically this, right? Right. So you are minimizing the wastage of space. Are you getting it? But if you define something like this, because you still have capacity, you have still capacity in RAM, you can have many. For example, if I say something like this, let's say in this RAM, you can define only, let's say, four integers. Okay, only four integers. One, two, three, and four. Only four integers. But in your program, you have to store eight numbers. How do you store it? You can't, right? Maybe you have used this much, maybe this much, maybe this much at least, maybe this much. But that's it. You can only store four numbers. You cannot store eight numbers. The way to do this is to simply use short, because you are only using small numbers. So why are you defining integer? Integer is a very big, I mean, you can do that. You can obviously, this is correct, this is perfectly fine, but this is just storage wastage, nothing else, right? So in that case, what you can, I mean, do is this. You can have, like, this is your RAM. Again, this is your RAM. You can define eight short, right? One, two, three, and four, 5, and 6, 7, and 8. You have 8 numbers now. Now let's say I'm defining 15,000. That's perfectly fine. I am not using the entire thing. But at least the storage usage, I mean, the wastage is very less. Like, I can, there is still wastage, right? There is still wastage, but at least it's very less. And that's fine. I'm doing my job, and that's perfectly fine. I have to store 8 numbers. I am storing 8 numbers. I'm happy, and that's it, right? Yeah. So this is the range, but I cannot do something like this. Remember, I cannot say short is equals to, I'm sorry, short, let's say Z is equals to 35,000. I cannot do that. Why? Because the maximum range is 32,767. 35,000 is out of range, and this will give me an error. I cannot do this. I have to stay in this range if I am using short. So remember that. Using short reduces storage space. I mean, reduces storage wastage. Then we have something called byte. Byte is even small. What is the range? 120 minus 122 minus 2, 127, right? What is the size of byte? Obviously, one byte, right? That's why it is a byte. What is the size of byte? One byte. What is one byte? 8 bits, right? I just said 8 bits is equals to one byte. One byte is equals to 8 bits, right? What is the size of one byte again? Obviously, it's one byte, right? So you can say something like this: byte x is equals to 110. Great. You are saving your space. If you are defining integer x, I mean, integer x is equals to 110. What is the maximum limit? Bro, this is too much. And you're using, I mean, just take out the percentage. This is clearly wastage, right? But what is this? What is the range of byte minus 120 to 127? If you're using byte x is equals to 110, this is much more efficient, right? Like, if this is my RAM, this is my byte. This is my byte, and I can use up to 127, and I'm using 110, maybe somewhere around this. I'm using this part. Do you see? Do you see? I have this much space remaining. I have this much space remaining. But if I had used integer, just in case, if I used integer would have taken this much, and I would have used only this portion. The entire thing is wastage. Only this part is remaining for this, right? So there is a wastage of space. So that's it. For byte, we can do these things. Again, we cannot exceed the limit. I cannot say something like this is wrong. If I say, like, maybe I say minus 1024, I cannot do that. Why? This will give me an error. This is the lower range, minus 120. I cannot go below this. I have to stay between this. I have to stay between this, and that is valid, right? Minus 128 up to 127. Both included as well. I can say something like this. I can say minus 128, minus 128. This is correct. This will work. I can say maybe, okay, hold on. I can say 128. Sorry, 127. This is correct. If I say 128, this is not correct, right? This is the maximum range. 128 is bigger than 127. This is wrong. Okay. Now, what happens if you need a very, 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 very big number, but it's an integer? Let's say you need something very big, maybe 999,999,999,999, like something this big. Integer cannot handle it. Why? This is the lower limit. This is the upper limit. Integer cannot handle this big number. For this, you need to use long. You need to use long. What is the size of long? 64 bits, which is 8 by, how do you get it? 64 divided by 8. Obviously, you get it. This is the range. I know it's huge, right? It's absolutely huge. This is a gigantic number that it can handle. Uh-huh. So I can say something like this very cleverly. I can say uh, long x is equals to maybe 99999. I can just go on. I can just go on now. I can just go on now, right? This is valid. This is valid. But again, please do not waste your space by saying long x is equals to 100. I mean, I mean, this is the maximum capacity, and you're using 100. So this is a wastage of space, right? Do not do these things, right? Do not do these things. Another thing, just to inform you, for long, only for this thing, if you're defining something, uh, the good practice is to put a L, or maybe a small l or a capital, doesn't really matter, after defining it. So if you are defining something like this, let's say long x is equals to 99999, something like it doesn't have to be big enough. Like, you can do it. I mean, this is valid. This is a wastage of space, I agree, but this is valid. It can handle small numbers, although that is a wastage of space, right? this is the this is the minimum range, this is the maximum range. You can put any number in between, that is perfectly fine. After putting the number, the better practice is to put a L, just to show that this is a long number. Even if you don't put it, this is right. If you put it, this is right. If you put small l, even that is right. But this is the good practice, so I just thought of explaining it to you. So these four things can handle similar things: int, short, byte, long. But use it wisely. If you have very, 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 very small number, use byte. Will just reduce your storage wastage, right? So use accordingly. If you have a very, 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 very big number, use long. If you have kind of big number, use integer, or maybe short for this number. I guess this is the sweet spot. Most of the numbers come here, but just for the sake of using things, I will be using int, since this is a lot common. Yeah, because nowadays people don't really care about your space. You have like you have really 16 GB of RAMs, 32 GB of RAMs. Nobody cares about space nowadays. But when Java was invented back in the days, you had very small systems, you had very limited capacity, storage was very expensive. So back in the days, the data types did matter. The data types did matter back in the days. Nowadays, people don't really care. But yeah, that's it. These are the integer types. Okay, so we have kind of covered these things. Okay, the integer part is, now I hope you understand why all of these can handle integer. Okay, now let's come to floating point. Floating point is basically anything with a decimal, anything with a decimal, which is a dot, right? So we have two types. float and double. Let's check those out. So first, hold on. Yeah, all right. So first, I'll go with the more common one, which is double. Which is double. How do you define a double? It's again it's simple. Double. This is the data type name. This is the variable name x. Write any number with a dot. You can say 17, maybe very big number. That's fine. Dot 6624. This is a double number. That's it. Anything with a decimal, put it here. You're good. With a double, by the way, you can put a D at the end to indicate that this is a double number. This is valid. This is valid. Or if you don't put anything, even this is valid. So you can put this, you can put this, or you don't put anything, even this is valid. But remember, up to 16 decimal places this will support. Okay. Again, there is a issue of wastage. I'll tell you. I'll tell you. Okay, so this is float. How do you define a float? It's simple. Float, the data type, the variable name, and the number 17667.6624. Now remember, with a float, you must say f. If you do not say f, if you write it like this will be treated as a double, and you have said that this is a float, so Java will throw error. You cannot do it. Okay, so this number will be a double number. And what you are saying that x is a float. You cannot put double into float. You cannot do that, right? You don't do that. So after every float value, you have to put a f or a f, whatever you like, a small f or a capital F. It's your choice, but you have to put a f. Now, what's the difference? The difference is that up to 7 decimal places. What does this mean? This means that I can say x is equals to, let's say for example 12.66234, yeah, if this is valid, this is valid. Okay, let me do this. This is valid. But what is not valid? 66234219226. This is not valid. Why? Because float supports up to 7 decimal places, which is 1, 2, 3, 4, 5, 6, 7. Up to this it was valid. Up to this it was valid, but after this it will not be able to handle this number. So this will give me an error. I cannot say float x is equals to float x is equals to this number. Why? Up to 7 decimal places, and this exceeds it. So not really. How to handle this number? Yes, you're right. Use double. Use double. That's perfectly fine. If you say something like this, so let me say this. Let me say this. If I say something like this, double x is equals to 12.6623421926. This is perfectly fine. Why? What is the limit? Up to 16 decimal places. So this can go to 16. Is this 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? You can add even more things, 6, 2, 1, something like this, up to 16 decimal places. So you getting it? You getting it? This is float. This is why is it double? Why do we call it double? Because what is the size of float? 32 bits, which is 4 byte. Why? How do I get it? 32 divided by 8, 4 byte. What is the size of double? 64 divided by 8, you get 8 bytes. So the double of this, 4 twos are 8. So the double of float, or 32 multiplied by 2 gives you 64. That's why this is called the double. Okay. Again, there is, like, if you have to store a very small number, something like 14.23, it's better that you use a float. Okay. But again, nowadays people directly use double just to reduce complexity, and this is good. Nowadays people don't really care about your space, so we are good. Okay. Then comes Boolean. How do we define a Boolean? We say bool. x, and this can either be true or maybe y is equals to false, and that's it. You cannot do anything else. For char, it can go from 0 to 255, or you can put any character. I hope you understand this, but this might be a little bit confusing. Let me show you. So for char, you can say char x is equals to a. This is correct. Char x is equals to maybe z, small z, or maybe small j. This is correct. But char x is equals to 65. Now you might say this is a number. This is a number. But this is valid. Anything from 0 to 255. But what will this give? What will this give? What is 65? Let me open my browser and show you to what's happening. If I open up my browser, ASCII values alphabets. Okay, I'll show you some images. Okay. Okay. See this very carefully. What is 65? It's A. What is 66? It's B. What is 67? It's C. Like this. What is 97? It's small a. What is 98? It's B. Right? Small b. So these all are characters only. Right? Do you see this character? So you can store numbers, and that is perfectly fine. Okay, you can do that. So that's about it. That is all about character. Nothing else. All right. Okay, let's define these things. What is this? Well, you can put int. You can put int, right? You can say you can say int x is equals to 154. That is correct. That is correct. You can also say short x is equals to 1234. This is also correct. Why? The range of short is starts from minus 32,000 something. Okay, this is correct, and up goes up to 32,000. So this is also correct. Um, you can say long. This is a wastage of space, I know, but yeah, this is valid. But you cannot say byte. Why? The range of this is wrong. The range of bytes starts from minus 128 and goes up to 127. This is 1234. This is not valid. Okay, you cannot say byte in this. Okay, what is this? This is a string. What is this? This is a single character with a single comma. With a single comma. What is a single comma? Char. What is this? It ends with a F. This is a float. What is this? It has either true or false. This is a bool or boolean. This, what is this? Obviously, it's a double. Can it be float? Yes, but for that you have to put F. But by default, if you see something like this, just say double and we are good. So we have covered this and this and this. So we are done with the primitive data types. String data types, you know what to do. Array and other things, classes and other things, we'll learn those things later on. All right. So this is just for your reference, just so that you understand. This is in you know, uh, it goes from smallest to the largest. Okay, like this, smallest to the largest. Boolean. Okay, I forgot to mention what is the size of boolean. What is the size of a boolean? Boolean can either be true or false. What is a true or false? What does computer understand? True means 1, false means 0. What is this? This is a bit. This is a bit. That's it. It can either be 1 or it can be 0. So, so basically, the size of boolean is one single bit. It can be true, it can be false, it can be 0, it can be 1. That's it. Only a single bit, right? That's it. So size in bits, only a single bit. Bytes, it is not a byte because it's just a single bit. Okay. A range either true or false. That's it. Byte. What is the size of byte? 8 bits, obviously. I mean, what is the size of a byte? 1 byte. That's it. What is 1 byte? 8 bits. Minus 120 to 127. That's it. Character, the size of character is 16 bits or 2 bytes. How do you get it? 16 divided by 8, right? If 8 bits gives you 1 byte, 16 bits gives you 2 bytes, right? It can be from 0 to 255. Why I have mentioned every English character that you see has an internal character assigned to it. For example, 65 is the capital letter A, 97 is the small letter A, but or things like that. Or it can have any character. That's fine. Short value. I mean, the size of short is 16 bit or 2 bytes. This is the range. Int 32 bits is the size or 4 bytes. This is the range. Float 32 bits is the size, 4 bytes, up to 7 decimal places. Double 64 bits. This is the big one. Size in bytes, 8 bytes, right? 64 divided by 8, you get 8. Up to 16 decimal places. Long 64 bits, again 8 bytes. And this is the range. Okay, this is a big one. I can't even pronounce this. So big. Anyways, so that's pretty much it about the data types. Now let's start with the practical aspect. Okay, let's open our Java, I mean BlueJ. Let me open BlueJ, right? Okay, let me create a new project. Let me say variables. Cool. How do you do this? New class. Type in anything. I might say uh first, right? Because this is our first class. Say okay. Go in. You know what to do, right? You know what to do. Delete all these things. You do not need these things. You just need public class first. Remember? You don't need anything. Oh yeah, mind the bracket by the way. Now write the main method. Public static void main string args. You can put the bracket after string or maybe after args, that's fine. Open and close the bracket. Inside the bracket. Okay, so this is the structure of, as usual, the Java program, right? Now we are about to define our first variable. Let's go start with an integer. How do we define an integer variable? Int x is equals to 1 2 3, right? That's how we define it. 1 2 3. That's it. That's how you define integer variable, right? Or there is another method to define. You can say int x. You define this. Then you say x is equals to 1 2 3. Whatever you like. You can do this in 2 lines. This is called defining. Oh, by the way, whenever you see I'm using these two things, these are comments. These are not code. You can write whatever you write. These are not going to execute. So this is a comment. So first I'm defining this, then I'm assigning this. Assign. So first defining, then assigning. So there are two steps. Or you can do both the things together like this. Int x is equals to 1 2 3. So you are defining and assigning in the same place. This is my preferred method. Use whatever you like. Okay. All right. How do you print a variable? It's very simple. System dot out dot println. Just type in x. That's it. It will print our variable x onto the main screen. Let's save this. Okay. Let's compile. Let's see if there is any compilation error. Class compile, no syntax errors. Let's close this one. You go to this. Press void main. Select OK. It's printing 1 2 3. We are good. So this is how we are defining our variables, right? Okay, let's try a few of these more. What happens if I type 12.3? Is this gonna work? Oh, it's going red. Why? Incompatible types, possible lossy conversion from double to int. Cannot do this, right? You cannot do these things. This is integer and this is a float or a double. So this is not compatible. This will give you error. If I try to compile this, this will not compile. This will give me compilation errors, right? So remind that. Also, I can use, okay, let me try the other things. Can you use a byte? Maybe 100, 110. This is cool, right? The same way. System.out.println x. You can keep whatever name you like, Just save this thing. Again, you just compile this. It's compiled, right? Or you can do it from here only. No issues at all. Go here and compile this. Class compile, no syntax errors, right? There you go, and right click, void main. Okay, it's printing the value 110, right? So it's working. It's cool, right? Uh, but what if I do this? Will this work? No. Why? The maximum range of byte is 127. This is 1034. This is not gonna happen, right? It's not gonna happen. So I cannot print this thing. This will give me a compilation error. I cannot do this. So just mind the ranges, okay? I can do something long because okay, this is a bit funny because long is very, very long. You can do this. You can type in long, you can type in int, you can type in short. Why? Because the short, range of short is, I guess, around 32,000. So you can say 32,000. This will work. This will work. If I compile it from here as well. There are two ways. It's working. But however, if I'll just open it once again, let's say I make it 35,000. Will it work? No, it will not work. Why? The range of this is exceeding, right? It was 32,000 something, and this is 35,000. So this is not going to work. So that is how we can do our stuff. All right. So let's solve a problem right now. Let's say we have. Okay. Let me go back to the blackboard once again. Let me go back to the blackboard. So let's say we have something. Let's solve an algebraic problem. We have a variable x. We have a variable y. The value of x is known, 120. The value of y is not yet known. The addition x plus y gives you maybe 200. Okay. So can you find the value of y from here? Yes, that is absolutely possible. What do you do? Y is equals to 200 minus x, and you get the value of y, right? Let's do the same thing. Let's do the same thing. So let's say int x is equals to 120. So the value of uh, x is, and let's keep it byte. I'm saving storage. Byte x is equals to 120. That's cool. You also have a, you also have a, you also have a y, right? But you don't know the y, you don't know the value of y. So let's define first. Let's define first. You have byte y, you have byte x. You know the value of x, which is 120. That's fine. But you don't know the value of y. You know the value of x. You have written it. All right. So this is how you can directly declare multiple variables. You can do this. Either you can do this, or you can even do this byte y or byte x equals 120. It's your choice. I personally prefer the first way. I'll just say byte x, or maybe byte y, byte x. I mean, it's directly taking byte, right? Y is byte, x is byte, and I'm directly typing the value of x is 120. Perfect. How do I get the value of y? How do I get the value of y? It's simple. Uh, System.out.println. What's the value of y? The value of y, let's say, or again, let's say the total value. The total value. Um, let's say y, z is the total value. What is the z's value? Let's say 200, right? X's value is 120. Now you have to get the value of y. We already know. Okay, you cannot do this. Oh, I'm sorry. It's exceeding. It's exceeding. Uh okay, no issues. No issues. I guess we can just keep it in. Z is equals to 200. Yeah, cool. Yeah, fine. All right. How do you get the value of y? We already know that x plus y is equals to z, right? We already know that the value of x is 120. We don't know the value of y, we know the value of z is 200. So what we do, we say, oh, by the way, these are all comments. This is not a code. I am just writing it down in English, right? So what is it? What is y? Y is equals to 200 minus 120, right? Z minus x, right? So it's that simple. I can simply say system dot out dot println uh, z minus x. Okay, I'll save this. I'll compile this. Class compiled, no syntax errors. Uh, okay, let me go back to this one. Right click, run this. Okay, so the value of y is 80, right? Z minus x, it gives you 80. So that's how you do it. Cool. But it's better if it shows something, right? So you can do something like this. The value of y is, put this or maybe this, whatever you like, but and put a plus symbol and put this in a bracket as well. Okay, we'll understand about operators and how the print function is working. But well, just for now, understand this and this will be combined together, and this addition is not really adding things, it's really pasting things. Okay, we'll understand this more in the next video. I'll compile this once again. Class compile, no syntax errors. I run this, run. The value of y is 80. That's cool, right? All right, so how is this happening? If you are really curious about this, this plus thing is actually combining is, for example, if I just uh okay, let me comment this out. Okay, let me stop for a moment. Let's say system dot out dot println. I say hello. I say plus world, right? If I do this, if I compile this, what will happen? What will happen? Let me run this. Do you see hello and world is coming together? It is coming together. We'll understand about how the println function works in depth in the next chapter, in the next lesson, where we understand about operators, how the print function works, how to take imports and everything. Okay, so this is the end of the class. I hope you have understood all about data types, constants, and variables. Oh, I missed constants, right? I missed constants. Okay, hold on. I missed constants. Uh, okay, let me check. I said first, right? Not this one. I guess I forgot it. I forgot it. I guess I'll open a new project. Open recent, maybe recent. I guess this was the last time I was showing you the code. Okay, anyways, I'll show it here only. How do you define a const? Okay, const also, every data type, every constant or a variable has to have a data type. All right, so I can say const, I mean const int x is equals to 123. This is perfectly fine. Okay, oh, not this one. Const. Okay, something is happening with this. Hold on. Okay, this is how you do it in constant static. const x x. Oh, 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 I was using the wrong keyword of word. Static final int x. Okay, this is how you define constant. It's not taking really. What's happening? Oopsie. Okay, somehow it's not working. Check. Oh, okay, okay. I'm sorry. You have to define things here, not here. So it cannot be instance variable. Anyways, whatever I say, I don't really, you don't really have to understand because you don't really have constants in your syllabus, so you can ignore that. But yeah, this is how you do it. Uh, like this: public static final int x is equals to 100. That's 120. So this is your constant. So final keyword makes it constant. Okay. If I somehow try to change, let's say x is equals to 115. If I try to do this, I should get an error, right? Yeah. Cannot assign a value to the final variable x. You cannot change constants. So constants are values which cannot be changed. So that is what I wanted to say. You don't really need to understand how to define constants and do all these things. It's fine. I was just showing the concept of constant. So you cannot, if there is a constant in your code, you cannot change it. If this was a variable, you could have done it. But this is the constant. How do you identify a constant in Java? It's final keyword. Okay. All right. I guess we are good. Variables, constants, data types. Yep, 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 yep. We are good. All right. Thanks for watching, guys. If there are any doubts, reach out to me via email, WhatsApp, anything. Okay. See you in the next lecture. Bye bye.